Hi, welcome to this new video on support conditions. In this video, we're going to see some pictures wherein we'll see certain kind of supports, and we'll also discuss how these supports are going to be idealized and what are the reactive components that develop because of the support conditions. Okay. This first one, we have a picture wherein we see these beams are supported on rollers. Okay. So what is going to happen here is these rollers are idealized as we see here. In this case, we see that these rollers permit the displacement in this direction, okay, as well as the rotation of this beam. However, we see this translation along y direction is not permitted, right? That's what we are going to summarize here. So ux displacement along x direction is possible, rotation is possible. However, the displacement along or translation along y direction is not possible. So whenever you arrest a particular displacement, the reactive component pertains to that do develop. Okay. So we see that when ux and theta z are allowed, the reactive components do not develop. However, when the displacement or translation or y direction is arrested, the corresponding reactive component does develop. Okay, Vy does exist. So in the free body diagram, we get only this reactive component Vy because we arrest this displacement. Fine. Let's move on to the next one. The second one is the pin support. Okay, we see this pin supports here. How we are going to idealize this? The idealization is something we are familiar already with. The idealization looks like this. So in this case, when here you can see that this is not going to allow this movement and this movement. However, the girder can undergo rotation, right? I'm not showing it properly here, but you need to understand that this rotation is permitted. Theta z is permitted, right? So that's what we are seeing here. The translations such as uy and ux are restrained, which means the reactive components relevant to that do develop, right? So in the free body diagram, we see that Vx and Vy exist, but not the reactive moment, right? So, and in this picture, we see that this beam rests on the columns, okay, in the fashion what we see here, right? So, what is the way in which this idealization could be possible? The idealization is done as simply supported one. Why? Because this displacement or this translation is only arrested here, which means ux and theta c are possible, and it also implies that therefore vx and m are 0. Okay. However, uy is not permitted, that is, this displacement is not permitted, which means only that reactive component vy alone develops. Okay, that is what is shown here. Okay, this vy alone is shown here. So this is what one calls as simply supported condition. All right. So next we will see this frames here. Out of them, we just take this ABCD. Okay, ABCD alone is taken here and shown here, depicted here. So this bases such as C and D, okay, are idealized as fixed ones. All right. So usually it depends on the kind of foundation one has and also the geological stratum available underneath. Okay. Here we see that the idealization looks like this, wherein the displacements such as Ux and Uy are not permitted and also the rotation is not possible. Okay, which means the reactive components Vx, Vy, and M, they all do develop. Okay, that's what is shown here. The free body diagram, we have to show Vx, Vy, and MC. Right? So both these ends, C as well as D, are considered to be fixed one in this case. In practicality, that means in reality, all joints are semi-rigid. Okay, we usually go to the extreme cases to make the analysis simpler. That is, the pinned one as well as the fixed one are extreme conditions. Usually, the intermediate one called semi-rigidity is what the reality is. Okay. And what about these two connections? Okay, they behave like when we carry out the analysis, we carry out the analysis considering this as a continuous beam. Okay, so these are intermediate supports here. Therefore, here the rotations need not be zero as such. So we can't say these are fixed ends. Right? Then we have this 3-pin arch here. So these two ends behave like pin supports, whereas we have a moment release here. Okay, that's what we see here. A, C, B. Alright. So the realization goes like this. These two ends are pinned ones. However, we have a moment release here. What is going to happen at a moment release? We know that the bending moment should be zero here. What else? However, the axial force and shear force need not be zero. Right? They are not zero. And how about the kinematic quantities? The displacements such as ux and v, ux and uy are single valued. However, there is a slope discontinuity at this location C, which is indicated by this. Right? And if one is interested to know how the hinges are achieved in a concrete structure, one can go through this particular article wherein these three kinds of hinges are discussed. All right. So what we see here is the arrangement of reinforcement. All right. And finally, we have the general kind of connections that one comes across in a steel support, sorry, steel structure. Okay. So first one is called the moment connection. What happens in case of moment connection is the flange of the beam, okay, is welded to the flange of the column. Okay, welding is carried out. When that is the case, what happens is the relative rotation of these ends are not permitted. Okay, so therefore, this behaves like a rigid connection, which means it is going to allow the transfer of moment and shear from beam to the column. And then this is called moment connection. On the other hand, we also have what is called shear connection. By the way, these images are taken from this website. We are thankful to this website. So in case of a shear connection, you see that the flanges are not attached, flanges of beams are not directly connected to the flanges of the column, which means the relative rotation of these flanges are permitted. Only the web of the beam is connected to the flange of the column. Right? That's what we see here. It means only the shear forces are transferred from the beam to the column and the moments are not transmitted. Okay, not transferred from beam to the column. And then this is called a shear connection. Alright. So hope this helps. We'll see in the next video how to determine the reactions for certain beams and frames. Thank you so much for your passion. See you.